Here's what we
Alright guys, we're group 14 and our project is the SS Special. Unfortunately, we don't have an actual toy today because we never received 3D parts from the company that was supposed to print them. So we're supposed to get them today. Hopefully we'll have one by the end of the week, but I'll let you know. My name is Alejandro Lavernia.
I'm Caleb Kerr. I'm Wissam.
And I'm Malachi.
This is the SS Special.
Alright, so I'll start off by introducing our toy. So our target audience was the ages of 10 and 14. We wanted to include road enthusiasts, boilermakers, and kids interested in robotics. Specifications, this is an amphibious vehicle, so it's able to travel on land and water. Along with that, to build it, we used two microcontroller and two servo motors. The play value, one of the mechanisms you actually have to move by hand. That increases the play value, and the toy itself you can actually program it with a microcontroller, and then program motion. So now I'll pass it to Caleb.
So I'll talk about some of the inspiration for our design. Obviously, the first thing that inspired our design was the Boilermaker Special mascot. We built our toy to resemble the cab of the Boilermaker Special, so just the section in front of where the people all sit in the back. Additionally, we wanted to use some inspiration from paddle boats, specifically early 20th century river boats. As you can see there on the right side, you'll kind of get an idea a little bit later on how we incorporated that. But they have the two separate paddle wheels that drive the vehicle into the water. Additionally, we wanted to make our vehicle look more like a train, and so we were going to incorporate a train wheel linkage to power our actual wheels. So we'd have a separate drive wheel that would power a different wheel in the back. Here's some of the sketches we had for our design. At the top, as you can see, our paddle wheel is incorporated very early on, while as we decided to do amphibious later, our design started to change. Pass it back to me. I'll kind of talk about the train cab itself.
So the train cab, so we specifically made it to match the Boilermaker Special. We had to make it a preview thing. The part was very hollow, and when we initially made it, it was very dense, so we had to meet the specifications of the 3D printer. Also, all edges was rounded for child safety.
Alright, now we'll work on the mechanism. So the first mechanism that we did was actually a manual slider. You can't really see it here, but it's right here. This is the slider. It allows you to adjust the SS Special from being able to operate in the water to be able to go on land. So as you can tell, when it's in water mode, you can lift the wheels up, therefore just cruising through the water, and then you can drop them down to move it into land. Because of the rotation and the locking mechanism that we put, you don't have any feedback in terms of flipping it up when you're driving along. But obviously, we couldn't test that since we didn't have a prototype.
So here are the paddle wheels with the drive wheels. The paddle wheels operate independently, which means if they're controlled by two servos, so if you want to turn right, you would have to spin the left paddle wheel faster, and vice versa. And the wheels are connected by a 4x linkage with the drive wheel. And the paddle wheel also acts as not just a paddle wheel, but as a wheel on land, so it propels for both water and
I'll talk a little bit about the electronics that we used. We worked with Holu Electronics and Robotics for a lot of our parts. This is a picture of the servo that we used. This picture on the right is the microcontroller we also use. It's about the size of a dime. It's really small, so we can fit it anywhere on the project. You program it based via USB cable. You can write a script very simply. A kid could do it probably in 2 minutes. It's really easy to figure out. There's also 6 channels, so if in the future we decide to add more customizations to the sensors or different motors and things like that, you can add that on as well. We've only got two of the board's channels used up at the moment.
So we're going to show you guys some simulations. The first simulation is the front wheels, so it's a pull down, the manual pull down and pull up for more from land to water, or vice versa.
So you can see it coming up. Now it's going to go back down here in a second.
second mechanism where this is a full motion of the whole project. You can see the 4-bar mechanism working with the paddle wheels and drive wheels, and the front wheels rising and lowering, going from land to water, water to land.
Does anyone have any questions for us?
So, I mean, are you able to get some follow-up?
Yeah. So we fixed it one way by we had to make both the ground link between the basically the two wheel centers exactly the same length as the link on the actual model on the outside. And since our 3D printing with the MakerBots isn't exactly a great way to get that tolerance right, we're going to laser cut that. If we can't get that to work, we have some tolerances built in, so it should still not hit that toggle point. We're not really expecting to hit that in actuality because there's inertia from the wheels, but if it does, we can put a belt around the wheels and they'll still function.
How do you plan on keeping it waterproof to like protect the motors and
So actually, that's a good question. I don't know if we have a picture where you can see it open, but yeah. So right here, basically, you see that it would be open underneath the train cab. We had a plan in place to use a piece of plastic and sort of, if you've ever worked with like peanut butter jar, you have a container lid. You can screw that on, screw it off, and that would allow you access to the internal components while keeping it waterproof. Because there are several components in here that would allow water in. So you don't want water being able to get in. So until we actually build the project, we haven't been able to implement such a plan, but it's very good.
So apart from the 4-bar mechanism, what problems do you anticipate if you get a chance to go to them?
One thing is definitely going to be waterproofing it. We're going to have to make sure that we caulk everything and seal it up real good and make sure that we don't have any water getting into our electronics and our boards. Another thing that we wanted to do that was met by our peanut butter jar type cabinet lid system, you need to be able to take our control board out and connect it to a USB cable. And if it's exposed, it can be exposed to water. So we need to be able to remove pieces without compromising the water.
Another thing is buoyancy. Right now, we don't know if it floats or sinks. We're pretty sure it floats, but if it floats too much, we will add weights, so balance it out.
One small question, the retractable wheels, what is the thickness on this thing?
I believe it's a 1/4 inch.
It says 1/4 inch. Yeah, the overall model, I don't think we discussed it, the overall model is actually quite large. It's almost 12 inches long and 7 inches wide. So it's actually